Hey, it's Tony from Adafruit, and in this video I'm going to look at how to display text on graphical displays with MicroPython. So displays like the Charlieplex feather wing, the LED matrix, or even like a Neopixel matrix, anything that you can draw pixels on, even like an OLED display or a TFT. I have a nice little library that I created, and if you saw the video stream that I did on Monday, I kind of went into some of the details about how you had to really deal with some memory optimizations to make it work. And now there's a nice little library that I've published that you can use to draw text on any of these displays. So this is great for like scrolling a little message across a display. I showed some examples, and we'll look at here, of like a little name badge that you could make that displays your name or something like that using like a feather and a feather wing to display it. So let's just kind of dive in and we'll look at this library and a little guide that goes along with it that shows you how to use the library. And it's really simple. It's pretty straightforward. As long as you can draw a pixel on a display of any kind, then you can draw text on it using a simple bitmap font. So we'll dive in here and see what we need to do. Let's see, we'll go to the main view real quick. Okay, so just like a lot of the other videos in the past, there's a guide that goes along with this. This was just published in the Learning System today, and I'll put a link when this goes up on YouTube so that you can look in the description below, and it'll link to this guide so you can just read the guide and follow along. And it's a real simple guide because really this is just a very software-focused guide. So you do need some hardware for this, obviously. So in the upper right-hand corner, I have, this is the Feather M0 board right here, which you can't really see because on top of it is the Charlieplex feather wing. So this is a 15 LED by 7 LED tall matrix of LEDs, and that they can all be individually controlled, and even the brightness of them can be controlled. There's a whole separate guide on how to use this with MicroPython. I'll put a link in the description below, and actually this guide right here links to it also. So again, this is a display that looks like a grid of pixels, so you can turn each of these little LEDs on and off individually, like even control their brightness. And that's exactly what I need to be able to scroll text or even just draw text across this display using this library. So I'll show you how to do that on this display. And then we'll look at another example too after we look at the Charlieplex display. But you could use this, for example, with the LED feather wing or even the breakout boards. You know, again, anything that has pixels that you can draw, you can use with this display. And then in this video stream, we'll look at something that I haven't looked at recently, but we'll look at a Neopixel grid. So this is actually the Arduino Shield for Neopixels. This is an 8x5 grid of pixels, and on the back of this one I actually have a Feather M0 ADA logger, like just has the SD card on here, and this is a little magnet so that you can wear this as like a name badge. But we'll see how we can scroll text across this also, or at least draw text on it for this one. So we'll just kind of dive in here and look at this guide. It should be pretty straightforward and pretty quick to make this work. So let's look at the hardware for this. And the hardware page for this guide is really simple. Like I said, this is mostly a software-focused guide. So I just linked to some of the other guides that talk about, like if you're using the LED backpack or feather wing, you know, this guy right here, you want to look at this guide. If you're using the Charlieplex one, like I've got on the board right now, look at this guide. I mentioned the SSD1306 OLED display, which I don't have handy right here right now. But that's another pixel-based display that you could use. The new TFT feather wing, which I just got one in, so maybe next week we might see a guide on that one. You could use that, or even like a Neopixel matrix you could use. So again, if it's got a pixel function that you can call to draw a pixel, you can draw text on it now with a really cool little module here. So the meat of this guide in this video is really going to be the software. So there's a little library that I created, and it's up on GitHub here. It's called the Adafruit BitmapFont library. And so it's real simple. It's based on the GFX library, which is a library in our Arduino world. And that's kind of the base of all of our graphical displays. So things like Arduino LCD shields or TFT shields, even little OLED displays and things like that that you might use with Arduino. All of those use this GFX library, which has built in like line drawing, circle drawing, font rendering, you know, drawing text on displays, and has a really simple 5-character wide or 5-pixel wide by 8-pixel tall font. Real simple basic font that you might have seen, like, you know, back in the old computer days when you only had like a 320 by 200 pixel size display. You would have these real kind of blocky fonts, but those are perfect for the displays that we're dealing with here, like these little, you know, 15 pixel wide by 7 pixel tall. That's pretty much tall enough to show the 5 by 8 font so you can show like at least 3 characters across. And even though you're missing 1 row, like this is 7 pixels tall, whereas our font is 8 pixels tall, this font is built so that for most of the characters, the 8th row, the bottom row, is blank. It's only a few of them, like the lowercase y and lowercase g, that have, you know, a little bit of a line that goes underneath them. That gets clipped off. So, you know, not the end of the world. It's still pretty visible and obvious what you're trying to do with these displays. You know, you could use a bigger display like the 16:8 matrix, LED matrix. This one's tall enough to show the entire font characters here. I mean, most of the characters are going to have an empty bottom row, but you will see like the lowercase y and g and things like that. So, okay, so let's go back to the guide then. And the way this works, so again, you want to go through and like I'm using the Charlieplex Featherwing here, and go through and follow the guide for that because you need to install the software for it. Like the Charlieplex Featherwing has its own little library that you need to use. You know, make sure that you can draw pixels and that everything's working before you try to do the font stuff, because it's good to just isolate things so that if you run into a problem, you hopefully figure it out before you've got everything together and are trying to troubleshoot 2 different things at once. And then on this board, so I've already copied the files over. But if I show you, so again, this is the SAMD21 MicroPython port that we're working on. And so it shows up as a storage drive. And I have on here the font5x8.bin file and then bitmapfont.mpy. So those are the 2 files that you need for the font rendering. I also have the IS31FL3731. I'm getting used to saying that now, .mpy. This is the driver for the Charlieplex display. And then I also have these HTK drivers. This is for the LED matrix display, which I'm not using here, but it's, you know, it doesn't hurt to have those on the board as long as you have the space for them there. So that's the first step, is you need to copy over bitmapfont.mpy and font5x8.bin. You have to have both of those files on the board for this to work, and you can get them from the release page on the GitHub release for this library. So just download both these files here. And then in the guide I mentioned, you know, if you're using SAMD21, if your board shows up as a file system, just copy the files over. If it doesn't show up as a file system, use a tool like Ampy, you know, something that can copy a file onto your MicroPython board. And then that's it. So we'll dive in now and start using this. So I'm going to open up the Python REPL, just the serial REPL on this board at 11.5.200 baud. And okay, so the first thing I have to do is initialize the display. And again, this is going to be specific to your board and your display. Go back to the guide, like the Charlieplex guide in this case, since I'm using that one, or LED Matrix guide. That'll tell you how to initialize your display. You know, you need to get to the point where you can draw pixels on that display before you can use this library. So in my case, I'll import the machine module and the IS31FL3731 library. And then I'll make an instance of the ISquaredC Bus, and this needs to know the clock pin and the data pin. So I've got the ISquaredC Bus, and then if I want, oh, and if you notice, I'm not doing the ISquaredC.init anymore. It's a recent change from the master branch of the SAMD21 Python stuff that I don't need to do that anymore. So it's a little small change that's maybe coming in the near future, although there's some bigger changes actually we're looking at with the SAMD21. Okay, so now if I want to, just to be smart, let's call ISquaredC.scan. Okay, cool. So I see there's a device. That means that my Featherwing is there and it's visible. Let's make an instance of my Charlieplex Featherwing, and so that's in the IS31FL3731 library .charliewing class, and that needs to take in the ISquaredC Bus. So I do that, and you see it kind of flashes a little bit, and the garbage collector happens to run because right now the drivers aren't super optimized to reduce memory allocation. So you might see, if you see this debug output, it's just telling you that the garbage collector is running. It's reclaiming unused variables and things. You can ignore it. It's output that, you know, doesn't hurt. It is good to see it so that you know, like, okay, something's allocating memory in this case. What happens when you initialize this class? It actually goes through, there are 8 frames of visible data that the driver chip can store, and it just goes through and clears each of those out. But in the process of doing that, it sends a bunch of commands which happen to allocate memory. So eventually we might hopefully get rid of some of those allocations, but it doesn't hurt in the short term. Okay, so now let's just make sure I can draw pixels. So with the Charlieplex matrix library, if I remember correctly, it has a pixel function where you pass the X and the Y position, and then the intensity, which is a value from like 0 to 255. So if I set 255, then this is going to say, okay, there's my 0, 0 pixel, and it's super bright, it's 255. Or if I want, I can go and say like, okay, only do 100. So it's a little bit less bright in that case. So this is good. So this kind of tells me that I can draw pixels, and here's where my origin is at, the 0, 0 position. So for this display, if I want to go all the way to the opposite corner, it should be 15, actually no, 14 across, because there are 15 pixels total. So 14 in the Y, in the X axis is going to be all the way at this side. And then if I go 6 down, then that should be the very bottom position here. So I do that, and then yeah, there, that pixel turns on. So that's good to just kind of tell me, okay, this is my display and this is the size of it. And then if I want, I can turn all these off just with the fill 0 command to just blank all the pixels. Okay, so now let's import the BitmapFont module. So import BitmapFont. And then at this point, I need to create an instance of the BitmapFont class inside of here. And I'll just call this BF. BF equals bitmapfont.bitmapfont. So this is basically the BitmapFont module, and then inside of there is a class called BitmapFont. Now this takes in a few parameters. The first one is the width of your display, the maximum width. And so in my case, it's 15 LEDs or pixels wide. And then the height, the maximum height, which is 7 pixels. It needs to know this just so that when it's drawing pixels, when it's drawing text rather, if it draws a character off the screen, it's smart enough to just not do any processing. It's not going to try and draw that. It just ignores it completely. Nice little optimization so that, you know, if you're drawing text in a loop, you don't have to do that logic yourself. You can just draw a long string of text and it'll clip off and only try to display the text in the visible area. And it'll save you a little bit of processing time, because the way this module works is it actually stores on the file system that font5x8.bin file. And go back to the previous video. I'll put a link in the YouTube description where I talked about why I actually store this font data in a file versus trying to store it in memory, because there's a lot of data in that file. It's like 10 kilobytes of text, and then in binary format it's like 1 kilobyte of binary data. But that it basically is a bitmap of each of the characters. There are 255 characters in the font, and every single pixel that makes up a character. So when you draw a character, you have to go through 5x8 pixels, and that could take a lot of time. So if you've got a long string of text and you're processing all of these invisible pixels, you're gonna waste time, which isn't worth it. So that's why this class wants to know what's your boundary, like what's the maximum size, so that it won't try to draw things outside of that size. Now the last thing is super important. So it needs to take in a function. So you need to pass in a function that is the pixel drawing function. And this is a really cool thing about this library. It's generic in that this library is not written to know about the Charlieplex display or the LED matrix display or a Neopixel display. It has no idea about those displays. It doesn't import those libraries. It doesn't depend on them. All that it needs to know is that it can call a function and pass it an X and a Y position at least, and then maybe some optional color data, which I'll show you in a second. And then it just needs to know that it can call some function to draw a pixel. It doesn't care where that pixel is drawn, like whether that's a Neopixel or an LED on the Charlieplex featherwing. You know, it might not even be a display. Like you might have some other thing, you know, maybe a file that you're like drawing ASCII characters into. You could do that. That's no problem. This class is meant to be generic like that. And this kind of shows the power of MicroPython, because this is a Python feature. It's a little bit of a dynamic language in that you can pass around functions as parameters. And you can do this in C and Arduino also, but it's not as easy, and it's certainly not as dynamic, and you can't do it in an interactive REPL like this. So this is kind of cool that you can write a library that's written against a function, and then you just pass in that function. And that function might be like the pixel drawing function in the Charlieplex matrix, or maybe it's a function you write yourself that does some transformations and other logic and then draws a pixel somewhere. And we'll look at that with the Neopixel display. But in this case, I'm going to pass in the matrix.pixel function. And even though this is a function, like I don't want to actually call the function, I just want to pass the name of it. And oops, I misspelled it right here. So matrix.pixel. So this is passing in the pixel function that's on this matrix object that I created ahead of time. And so that's the Charlieplex featherwing here. And you can do that in Python. It's an instance, a function that lives on an instance of this class. And so that's a perfectly valid function to pass in here. So this is telling my BitmapFont render, when you want to draw a pixel, do it against this display that I created ahead of time. And so that's the cool thing about this library. Okay, so I do this. Now the next thing I have to do is I have to call this bf.init function. And you've seen this before actually with ISquaredC. So because this library reads the font data from a file, I have to open that file and read it in, or at least keep a reference to it. And a file is a resource. It needs to be opened and it needs to be closed also. And so there's also a dinit function that you should call. So when you're finished with the file, call dinit, or when you're finished with your font rendering, call dinit so it closes the file. Now init and dinit are nice when you're working on the REPL here, but I did implement a context manager so you can actually do the syntax of, with bitmapfont.bitmapfont, and then the exact same parameters here, the size, the function that you want to call, and then you can say as bf. You can do this, and this makes a new block of indented code, and inside of here would be a variable called bf, and you don't have to call init at this point because the context manager will automatically do that, and it will automatically call dinit when it's done. The context manager syntax is nice when you're writing a script. It's less nice at the REPL here because it's all of your code is indented and it doesn't run until you actually finish the with statement, which is not usually what you want. So use either way. It's fine to use this, but just remember to call that dinit. It's not the end of the world if you forget to call it, especially if you're just like resetting the board. But if you're using like multiple font renders or things, you might get into a weird state if it's, you have multiple references to that file. Okay, so at this point now, it's actually pretty easy. There are just two functions. There's actually three, but two that you really care about. So the one that you really probably want to use is the text function. So this will draw a string of text on the board. Actually, let's say Adafruit's on here. I was going to say hello world, but I realized that it doesn't really fit all the way on here. So we'll say Adafruit. And then next you need to pass in the position. So where the upper left corner that it will start drawing the text. And in this case, let's just pass 0, 0 to this. Now those three parameters are required for this function. And then anything else you put after those parameters will just be forwarded to this pixel drawing function. So this is where you put like your color or other parameters that control how those pixels are displayed. So for my Charlieplex display, remember it takes that intensity value that's from 0 to 255. So let's say a value of, how about 100? So just kind of like, a mild intensity for this. Okay, so let's hit enter and hey, look at this. So you see A, D, and then the A kind of gets cut off a little bit. Now the reason for this, now remember each of these characters is 5 pixels wide, and then I put a blank column of pixels in between each character. So that's why you can't get all of these characters, even though it's 15 pixels across on this display. You get a couple that are cut off here because it's adding some extra columns in there. But this is kind of cool. I mean, if I wanted, I could go and let's matrix.fill0 to just clear it again. So, oops, I misspelled this again. So matrix.fill0. And then if I want, I could draw this, I could actually put a negative value here, like -5. So it's going to start a little bit to the left. Like imagine I was scrolling this display across. And so now you can see da is there. So, you get a little bit of the text being drawn there. Not sure why that pixel turned on. That's a little bit weird for that, at least a little bit unexpected. Oh wait, no, that's from the F. Sorry, I forgot that I was writing Adafruit. I thought I was writing Ada. So okay, so that's normal. That's expected. But anyway, so that's it. I mean, we're drawing the text, and again, like I mentioned, it's clipping off that A in the front, and so it's not even actually rendering that A character. It's just drawing the DA and then part of that F for that. So it's smart enough to do that. Let's clear the display again, and let's call another function on the BitmapFont class. So there is a draw_character. And this one, it's just like text, but it just draws a single character. So it's maybe not as interesting, but it is there. And the text function actually uses it. And just like the text function, any parameters you pass after this will be forwarded to your pixel draw function. So this is where you set like your color. So let's set like a higher intensity. So we'll draw an A character, you know, as bright as we can right there. So that's cool. You know, that works. We've got an A character, and we're all good to go with that. So that's simple. And then the one last function that might be useful, I put a width function on here. And so you pass in a string like Adafruit to the width function, and it will return back the width of that string in pixels. So the text Adafruit with this font that the library uses would be 48 pixels wide. And then I don't have a height function. Maybe I should add that in the future. But the height is fixed. It's 8 pixels tall for this display. So this is useful when you're scrolling a message. And I'll show you a demo in a second here where you kind of need to know like how wide is your message so that when it reaches the end, you can wrap back around to the front for that. So, okay, so yeah, let's look at a more complex example here. And actually, I put this in the library. If you go to the code on GitHub, I put an examples folder here. And so you can see there's a Charlieplex matrix scrolling example, which I think I actually showed in the previous video also. So we'll go through this real quick just to kind of show you a more complex example. So I'm just going to load this up here. And this is kind of a cool example in that you can change this message. You can define like the intensity that it's going to be. So like, let's maybe set this to like 100, so it's a little bit less intense. And then the code for this, I went through this, I think, in the previous video, but you know, basically I made a little main function that gets passed in an ISquaredC interface. And then this is actually the first thing that runs. It uses that context manager syntax and then calls main with the ISquaredC interface. And then inside of here, just like I was showing in the REPL, you know, I create an instance of the Charlieplex Featherwing. And then this is actually using the context manager syntax for the font renderer. And so again, it's just passing in the width and the height and then that matrix pixel drawing function. And it gets back a font renderer that it uses inside of this indented block of code. It will automatically call that init and deinit function, so you don't need to do anything crazy inside of here. And then I just keep track of like the position of my scrolled message, and it really just works by just moving that position to the left until it gets all the way far to the left that the message isn't visible anymore, and then it wraps back the position to the far right and just starts over scrolling again. And the way that it figures out how to scroll, it has a speed that you assign in pixels per second, and then it computes how much time has elapsed between each frame. It uses your speed as like a velocity, so elapsed time multiplied by velocity equals kind of your new position, or at least you offset your position based on that. And this little block here checks to see if it reaches the end and then wraps back around to the far right. I do a little bit of fanciness in here in that I use 2 frames, because remember that Charlieplex Featherwing has 8 frames, and those frames, one of them will be visible and then the other frame can be invisible. So I draw on the invisible frame, and when I'm done drawing, I swap over that invisible frame to be the new visible frame, and then what was my visible frame is now my invisible frame that I start rendering on for the next cycle through. So that way you don't see each of the individual pixels being turned on and off, which it happens really quickly, but you do notice flickering if you try and do that. So it's called double buffering, where you draw into an unseen buffer, and then when you're done, you just swap that buffer over so it's instantly visible and all of the pixels change at once instead of seeing like one by one all those pixels changing. And then here is where I'm actually using the font library to draw that text message on here. So again, just using the text function, and the X position is, you know, set based on this position variable, which I'm moving based on the velocity up here. So that's how it's going to scroll across for this. And then it just sleeps a little bit to give some time to the firmware. So okay, let's copy this, or actually let's save this as a main.py on my MicroPython board. So let's save this as main.py. And so I do that. And because I have my REPL open here, it's not going to auto reset. So I'm going to press Control D. D is in dog. And in the REPL, Control D will do like a soft reboot of the board. So now you see main.py is running, and we can see the message is scrolling across. So MicroPython rocks. Cool, so that's the message scroller. And this is exactly why I built this little font rendering class, because you know, you want to have neat little displays. This is on a tiny little Featherwing board. You know, this thing's really small. This one I actually have a magnet on the back. This is a name tag magnet. And then with that, you can actually clip this onto like a shirt and wear it as a name badge, for example, if you wanted to go to a conference or something like that. So really cool. And you can see this is the garbage collector running in the serial REPL right here. So something's happening. It's allocating memory, but it doesn't hurt it. You know, it's still scrolling. It still works. It's just periodically the garbage collector will kind of pause, see what memory is being used and what memory is not being used, and then get rid of that unused memory, reclaim it so that anything else, like new variables, can use it again. So that's again, like a powerful part of MicroPython. Like, I don't have to manage that memory. The garbage collector is going to do it for me. You know, there are trade-offs to that. It's not perfect. Like, you do lose some performance, but it's nice. The convenience is great to have that. So, okay, so that was the Charlieplex Featherwing. Like I said, the LED matrix, very similar. It has a pixel drawing function. You would use it just the same, and I actually show in the guide, I think, some more examples about that. But I wanted to do something a little more interesting that I haven't shown before. Let's pull this board out. I'm actually going to close this serial REPL, and let's unplug this, and then let's zoom out a teeny bit because I want to look at this. So this is the Neopixel Arduino Shield, which is a little weird. I'm not using it with an Arduino. So like I said, I have a feather that I taped to the back here and soldered to the pixel input connections here in the power and the ground. And I need to plug this into a battery because the way I've wired the Neopixels, they run off the battery voltage and not like a regulator. So they won't light if I don't have the battery connected. And then let me plug in the board to my computer here. Oops, let me get it the right orientation. There we go. Okay, and then it doesn't want to sit flat, so let's finagle it into a good position so that it actually lays flat. Let's see if that's, yeah, that's probably good enough, like that. Okay, so let's go and let's get some fonts to render on this display. Now this display is 8 pixels tall by 5 pixels wide. So that's perfect. It can draw one character basically. I haven't tried scrolling a message across this yet, but I bet it would work. You know, I don't see any reason why not. It's just, you might need to scroll it at like a fast speed so that you can see your characters kind of, you know, going across, and you'll be able to piece it together in your mind. You probably want to use like a larger matrix if you're really doing this for something, or maybe 2 of these matrices next to each other might be kind of nice. That would give you 2 characters. It'd be big, but it would give you more characters to deal with here. Okay, so let's open up our serial terminal. And for this board, I've actually already copied over, I'll show you on the MicroPython board. Again, this is running the SAMD21 firmware. So I have my BitmapFont.mpy and the font5x8.bin on here. I don't need a module for Neopixels. It's built in right now, so that's kind of nice. But I'll show you how we use this here. So, okay, so let's go and let's initialize the Neopixels first, because we'll just make sure those work. So we'll import machine, we'll import Neopixel, and then we'll create a Neopixel object that's based on the Neopixel class. And this needs to take in the pin that's connected to the data input line of the Neopixels. And in this case, it's digital pin 6, and it needs to be an output. So we'll do that. And then the class also takes in the total number of pixels, because even though this is in a matrix shape, you know, that it has like 2 dimensions, it really is just one long row of pixels. So it just goes down to the bottom and then loops back up to the top here and goes back to the bottom and loops up to the top. So it's just one long string of pixels. So 8 times 5, actually you can type that into here if you want. That's 40, but you know, hey, it's Python, it'll evaluate it. So we can do that. And then just to make sure everything works, let's fill it with like all red. Maybe not that intense. Let's do like 50, 0, 0. And then remember, with Neopixels, you have to call the write function. And so there we go, it lights up red. And then if I want to clear it, I can say fill with a color of 0, 0, 0, and then write that out and turns it off. Now let's see where the origin is on this display. So let's set pixel 0 to red. Let's say 100, 0, 0. And then let's set the next pixel to maybe green. So we'll just kind of see, you know, how are these pixels aligned. And then let's write this out. Okay, so now we see there's red and there's green. And so if I kept going, all of my pixels are going to keep going down. Let's do the 8th pixel, which should be the next one in line, just to make sure that we see that it follows that kind of ordering. So if I say the 8th pixel, which is actually the 9th pixel, because these are the first 8, and then the 9th one is there because it starts at index 0. Let's set this one to blue. So we'll say 0, 0, and then 100. And now let's write this out. And so, okay, yeah, so we do see, we go 8 down, and then back up to the top on the next row, 8 down like this. So if I wanted to draw a character, it would be in this orientation because it's going to start at 0, 0. And I'll show you how you can convert that, because this array of pixels is just one-dimensional. It goes from 0 to 40. It doesn't have a concept of an x and a y, but I'll show you how you can do that. But if I just tried it like this as is, I'm going to be drawing in a weird way because, I'm only going to have 5 pixels, but my font is 8 pixels tall. And I get more pixels across, but it's going to be cut off. So I really want to transform this so that I can draw, with my origin in the left up here. And so the way to do this is actually, let's make a little pixel drawing function. Because remember, to use that BitmapFont library, you have to have a function that takes an x and a y position. And right now, to set these neopixels, you have to index into an array. So that won't work for the bitmap function. Or BitmapFont library, but I can make a function. It's super easy in Python. Again, the dynamic kind of nature, even in the REPL, you can make a function and then pass it into something. So let's make a matrix underscore pixel function, and it'll take x, y, and a color value. And that color could be something like, this tuple of red, green, blue values that it'll use. Okay, so now we need to do a little bit of math because, at this 0, 0 position, I actually want to move it over to be this part of the display. Now, to convert from XY into this indexed array, what you want to do, and this isn't actually the code we're going to use, but I'll just show you an example. You basically want to take your Y position times the stride, which is the total number of pixels in a row. So in this case, there are 8 pixels. So basically I'm saying, imagine let's put the display in this orientation. So if I want to say position, 0, 0 up here, let's make something more interesting. How about this pixel below here? So this would be position, the blue pixel right here is position 0. It's in column 0, the X position 0, but then Y position 1. And so in this case, now remember, this is pixel 8, index number 8. So I want to do some transformation that converts 0, 1, X position 0, Y position 1, into just the single value 8. And so the way that you do that, again, you want to say you take your Y position, which is how many rows down you are. In this case, I'm 1 row down. You multiply by your stride, which is the number of pixels in a row, and then you add your X position to that. And so that's going to give you that single value in this case. And so, just do the math for this 0, 1 position. I'm going to have 1 as Y. 1 times 8 is 8. And then my X position is 0, so I'm not going to add anything to this. But, let's say I wanted like this pixel over here. That would have an X position of, let's see, 0, 1, 2, 3, so 3. So I would add 3 onto 8. I'd get pixel number 11, and that would light it up. So let's just use this function as is, and we'll set the color and just kind of see how this works. So let's call matrix pixel, and let's try to light up that pixel I said. So X position 3, Y position 1, so that should be this pixel right here. And let's set this to a color of about 255, 0, 255, like a pink, really bright pink color. And then again, I have to do the right function. And there we go. We get a nice pixel, pink pixel right there. And I can light up other pixels like this. If I want to go, let's go like 3 rows down. So I should be, a few rows down. And then let's write that. And yeah, there we go. We light it up there. So that's how you convert from that 2D coordinate into a one-dimensional index into this array. Really common thing you do in graphics. Okay, now the next thing, I don't actually want to do it in that format. I want to swap my origin so that instead of my origin being up here and kind of moving this way in the X position, I actually want my origin to be up here and to move this way in the X position. And again, it's just some math to do this. So let's redefine this matrix pixel function. It's going to take the same parameters, but now I'm going to do a little bit of transformation here. So I'm going to use the same basic formula here so that, you know, when I'm drawing XY to my pixel grid, it's going to use its native origin and kind of orientation, but I'm going to convert my input pixels or position into this kind of reference frame or new orientation. So I'm going to make a new Y position. So basically my Y position should be equal to my X, my incoming X pixel. And so basically this NPY is the Y coordinate in this frame of orientation. And I'm setting this to the X pixel of my input because this X pixel is in this orientation and it's going to go across because I want this, you know, to be position 0. So when it gets over here, this is position 1, position 2. And so when I swap this guy around into this format, it's actually the Y coordinates that I'm looking at here. But I actually need to do something else here because, you know, my Y coordinates go up here and move down, whereas my X coordinates are going to go here and move this way. So, you know, position 0, 0 is right up here. But if I just did this NPY equals X, you know, X position 0, which should be down here, is actually going to be Y position 0, which is up here. So I want to invert this by saying 4 minus. And so now it's going to say, okay, when X position 0, which is down here, it's actually going to pick Y position 4 minus X. So it's actually going to pick Y position 4, which is at the bottom here. So again, you know, you might want to slow down and kind of draw out the math and think about it, but I'm just kind of swapping the position of that axis in this case. Now the next thing is my X position, and this one's actually pretty easy. I'm just going to take the Y position because, so again, this NPX is the X position in this orientation, and so that's this left-right position. And my incoming Y position is actually in this orientation. And so my Y position is this up-down. And luckily it starts at the top and moves down, just like in this orientation my X starts at the left and moves across this way. So I don't need to do any transformation for this. So I'll just take the value as is, like this. Okay, so I've got those values, and now I'm just going to do the exact same thing as I did above. My Y position times the stride plus my X position, and then I'm just going to set that equal to the color. Okay, so now let's clear the display, np.fill with all 0, 0, 0, and then let's use our font render. So, well, actually, here, let's write this out. So we'll turn off the display. Now let's create our font render. So we'll say bf. Oh, I need to import it first. Well, actually, here, let's just test it out. So, you know, let's call our matrix pixel function. Again, you know, smart to test things out as you go with this, so that you're not troubleshooting a bunch of things. So let's say 0, 0 should equal the color 255. So red, like bright red. And then let's do np.write. And now if we did everything right, this should be pixel 0, 0 up here. So I do that. Hey, looks like we got it right. And let's try to get this bottom right one down here. So this one, that one should be 4 across, because, you know, it's actually 5 pixels across, but we're indexed by 0. And then it should be 7 down from the top. So I do that, and then I write, and hey, look at that. So looks like we got those transformations correct. And it's, you know, again, just kind of step through it, walk through the math, like write out the equations, and just see how it works if you don't really understand what's happening here, because it's not intuitive, but it does make sense once you kind of step through it and see how it works. Okay, so let's fill this with 0, 0, 0 again, just to clear it. Now let's make the font render. So let's do import BitmapFont, and bf equals BitmapFont.BitmapFont class. And now the size of this thing. So it's 5 pixels across by 8 pixels tall. You know, the size of a character basically. And now my pixel drawing function. And so I'm just going to use this function that I created before, this matrix pixel function. So I just pass in the name of that function there, and that's all that I need to do for this. And then I need to initialize this, and then I can say, okay, let's do draw character, since I'm only going to fit one character on here at a time. We'll say the A character, position 0, 0, And then the color, let's say, how about 50, 0, 50? It's like a light pinkish kind of color. Draw underscore character is what I should do. So draw character. And then let's call my neopixel.write. And hey, look at that. We have an A character on there. So it's kind of lighting up. You can see that. So that's cool. I mean, I could make a scrolling message with this if I wanted. And you know what? I do want to do that because I haven't tried that yet. So let's go to our examples here. So this is our main.py right now. And let's modify this. So let's remove this. That's the Charlieplex featherwing. I don't really need that. So let's initialize the Neopixel matrix. And my display width is actually going to be 5 pixels across by 8 pixels tall. Let's say instead of intensity, we'll say color. This is going to be my color of my message. So let's make that, how about a pink message to scroll across. And this comment doesn't make sense anymore, but we'll just keep it like that. Okay, so let's initialize that matrix. So np equals neopixel.neopixel class and machine.pin d6 as a machine.pin.output. And then the display width times the display height is my total number of pixels. And it's starting to kind of scroll off the message there. Okay, and then let's just fill with 0, 0, 0 to just turn everything off in this case. Okay, and then I need to create that function just like I made before. So let's make that matrix pixel function that takes x, y, and color. And I'm just going to take it directly from here. So npy equals 4 minus x. Say npy equals 4 minus x. npx equals y. And then index into my NeoPixel array, npy times my display height in this case. I probably shouldn't use display height because it's not really the stride, it depends on the orientation of this thing. So, you know what, I'm just gonna hard code this for now. This is just a quick and dirty script in this case. So that plus my npx equals my color value. Okay, so that's cool. And now I wanna pass this in for my function, that matrix pixel function. Okay, cool. So now let's see. I don't have any concept of frame. There's no double buffering with this, so I'm going to get rid of that concept. I do need all this time computation to be the same. Frame swapping, don't have to do that, so I'm going to rip that out. Clearing the display, yeah, let's do that. Instead, it's not matrix though. Now it's neopixel.fill, and this should take 0, 0, 0. So I do that, and then yeah, I do want to render this, and instead of intensity, it's going to be color now, and it's going to pass in this tuple of color values up here. So pink color. I don't need to swap frames anymore, but I do need to call my neopixel.write function. So we'll do that, and this, fingers crossed, should work. And actually, I don't even need this ISquaredC stuff right here. So let's rip that out. It's not necessary. I don't even need that. Let's rip this out. We'll just put a call to main in here, but you know what? I actually don't even really need to use main right here. So let's just rip out the whole concept of main and just make this the main block of code. So I'll just de-indent that. And this should work in theory. I haven't tried it, so hey, let's see what happens. We might have to do a little bit of troubleshooting. So let's save this as, I just want to make sure that it finds the board. Yes, there's my main.py. So let's save that. Yep, I want to replace that file. Okay, so now if I reset my board, let's see. Hey, see, so I had the REPL open. I pressed Control D to reset my board, and now you can see, so it's running the main.py. Like this is some output that we put in the SAM-D21 port, but I got an error. I forgot to import the Neopixel library. So this is good. This is a good example of how to debug this. So we'll say import Neopixel. Now here's the cool thing. I don't think I pressed anything, so when I save this file, I think it's going to auto reset and run. So let's see what happens. Yeah, let's see. It is running. Okay, now something failed here. Byte array index out of range. Ooh, that's not good. So I got something wrong with my pixel drawing, I think, right here. So let's see, X, Y. So it's trying to display my pixels here. I'm just trying to see, somewhere here I'm getting my array out of bounds. So like basically I have a feeling, this transformation, I might have made a mistake here. So it drew the M character, but then it looked like when it moved across to the next, let's see, so like line 49 and line 45, let's see, where is this? So it's drawing the text message, and then in the process of drawing that, it's gonna go, let's see, yeah, line 45, and then, okay, yeah, so that's interesting, it was sleeping before that. So, but anyway, so it's getting into the BitmapFont rendering, so it's drawing the character, and then it must, so I have a feeling what's happening here is I might have something wrong with, my pixel drawing function here. Let's just put in a sanity check so that if I try to draw a pixel outside of the bounds, I ignore it. So if x is less than 0, or x is greater than 4, or y is less than 0, or y is greater than 7, then just return. Don't try to draw that pixel. So let's save that and see what happens. There we go, that fixed it. So, obviously that maybe a good little point to kind of demonstrate here is that make sure your pixel drawing ignores pixels that are out of bounds. So that might be a good optimization I should look at for the library. Obviously some kind of pixel is slipping through that got out of bounds there. But you can see this is working. So it's scrolling across the message, MicroPython rocks. It's a little hard to see. I mean, I guess you can kind of tell. You've only got kind of one character visible at a time. Maybe what happens if we slow it down? Let's do like 15 instead of 20, or how about 10 instead of 25. So we'll save that. And so now MicroPython. So that's maybe a little more readable. Rocks slowly. There we go. So, but that's cool. So, I wanted to demonstrate that's the flexibility of this BitmapFont rendering library. Anything that you can draw a pixel against, you can draw text on, and that's showing the flexibility of MicroPython in that, I'm just changing this function that I pass into this library. So my library has no idea that it's drawing text on a Neopixel display. It just knows that it needs to call some function to draw each of the pixels of these font characters. And then it just goes from there and draws out your text for that. So that's all that I wanted to show in this video. I just wanted to go through this guide that shows how to draw text on pixel displays. I explain a little bit about how it works and how you can use it and extend it to do really cool things. I mean, I could imagine, you can make some really neat like physical display where, I've seen like sometimes they have like mirrors, and they'll like maybe they have like servos attached to them that like will move and reflect the light, and all those mirrors like make up pixels in a big grid. You could do that, and draw text and have text scrolling across it. Just have some function that figures out which servo defines each pixel and how to move the mirrors and things like that. So if you do a cool project like that, show it on Show and Tell, because we would love to see neat stuff like that, especially if it's using MicroPython. So, okay, that's it. If folks have questions, throw them into the chat, and I'll jump back to the main kind of view here, and we'll see if we can get to them. So let's see. So did you run into any memory problems with double buffering? No, I didn't run into any memory problems with double buffering because the buffer is actually stored on the Charlieplex wing itself. Like the driver chip on here, it has memory for all 8 of those frames. So they're not stored in memory, which is kind of nice. When you draw pixels, you just say, I want to draw against this frame of data, and it tells the chip, okay, switch to that frame and then draw your pixels there. So that's all good. Let's see. Does MicroPython support object factories? Object factories, I don't know. I don't know of a Python construct called an object factory, but like in the object-oriented world, a factory is usually like a static function that creates an object. And so, yeah, you should be able to do that in Python. Something you see a lot is static or global functions inside of modules. So like, you could create a module, put a bunch of top-level functions, and those functions can create objects and return them. And so that's maybe like a factory in the sense of, you call some function and you get an object back. And, you might want to do that if like constructing an object requires, maybe knowledge of other objects or something, and you want to have some function you're calling that maybe, or maybe you want a single instance something like, not necessarily a singleton, but you call some function that maybe keeps track of how many instances of this thing has been created and will give you back an instance or something like that and hides that from you. So yeah, you should be able to do that. And it is kind of common in Python to put global functions in a module and then use those for this. So let's see if there's anything else. So cool, I think that was it. So yeah, and again, this was just showing off. Let's see if I can get this into the frame here. So yeah, this is kind of cool. The scrolling display, MicroPython rocks. So that's it for this stream. Check out youtube.com/Adafruit. You can see this video, all kinds of other fun project videos. Check out twitch.tv/Adafruit. That's where I like to stream these things live. So I usually do a stream on Tuesdays and on Fridays. And I think next week I'm probably going to look at the TFT Featherwing. So it's a nice little graphical display. I'm curious to see what the SAMD21 can do, because the TFT display, it's kind of large, has a lot of pixels, and so we'll see if you can get some good performance from it. But who knows? You might want to actually use a more powerful chip, especially if you're trying to do like animation and fast graphics and things like that. I did hear a cool thing. So when I was at the Super Conference in LA last week, I was talking to Paul Stoffergen, the Teensy creator, and he had the Teensy 3.5 and 3.6, and he was saying a cool thing that he saw was someone who created full motion video at 30 frames per second streamed off of an SD card using the Teensy 3.5 and 3.6. So that's pretty impressive, like doing real video fast enough to be smooth and fluid, all from a tiny little microcontroller. So that's cool. I don't know if MicroPython is going to be able to be that fast, but we'll try. We'll see what happens with that. So look forward to that next week. And then otherwise, just like, comment, subscribe, let us know that this is good stuff, and we'll keep making content like that. So until next time, I'll see you guys later. This is Tony from Adafruit. Bye.